Alright guys, we're working on another Liebherr loader today. This time the problem is air conditioning. The air conditioning in the cab is not getting cold. Today in Oklahoma City, it's about 90 degrees, so some AC would be perfect right about now. And it's not working on this machine, so let's dive into it. First thing I do is check cabin air filter. This one's pretty nasty, so we're gonna get it replaced. It wasn't the problem. I took it out and our AC temperature did not decrease. So not our problem, but still gonna get replaced because this is definitely a preventive maintenance item. Okay, so after checking our cabin air filters, the next thing we're gonna do is tie in our AC manifold gauge to our service ports. We will look at our pressures. This compressor is cycling a lot, so we're gonna wait for it to turn on, and then we'll check our pressures once this compressor turns on. All right, our compressor is turned on. Let's take a look at our pressures. We see our high side climbing. We see our low side decreasing, which is good. So right here, we're still looking at pretty good for a 90-degree ambient temperature. We'll wait for that compressor to cycle off and see what our pressure's at when our compressor cycles off. All right, we just cycled off. So we're at about 260, 270 maybe, and our low side was at 235. Those are actually perfect temperatures for an ambient temperature at 90 degrees. So why is it cycling? Our compressor should only be cycling if our low side gets way too low or our high side gets way too high. Currently at this temperature, our compressor should stay running, keeping that evaporator nice and cold. So next we'll check our airflow. All right, we've got the cover off of our airbox here. Here's our heater core. Here's our AC evaporator. There's our blower motor. Our blower motor is working perfectly. It is bringing air in, moving it across our evaporator, and moving across into the cab. So if we've got good freon in this system, we've got good airflow, our high side is not increasing, our low side is not decreasing, something is telling this compressor to turn on and off. Well, this machine has a fully automatic AC system, which means it uses a module to control inputs and outputs. Luckily, we can plug into that module so we can see what inputs that module is reading and what outputs it's giving to our components. All right, here are all of the inputs and outputs that our AC module is seeing and controlling. So if we zoom in, we can see our temperature in the cab, 35 degrees Celsius. If we translate that to freedom units, that's about our ambient temperature. So about 90 degrees, 94 maybe. Our temp out, same thing, that looks good. Whoa, look at our AC evaporator temperature. Negative 128 degrees Celsius. That's almost negative 200 degrees Fahrenheit. There's no way on earth our evaporator is actually that cold. But because the machine is picking this up as such, it thinks our evaporator is freezing over. So it's continuously cycling that compressor, trying to thaw the evaporator out. So because of this value, it's cycling our compressor. Let's see if we can find that evaporator temperature sensor. So right back here, that is what Liebherr calls that picks up a value, but it picks up the temperature of the evaporator and sends it as an input to the module. Then the AC controller knows whether to keep the compressor engaged or to turn it off. If this gets way too cold, the controller will shut the compressor off so this doesn't freeze over. So I'm going to try and trick the system here. I've got two resistors. We're going to put a 10 kilo ohm resistance value on that plug right there. That's our anti-icing plug. Our resistance value on here read about 700 ohms, which is way too low. That value translates to about negative 128 degrees Celsius. So if we put a much higher resistance value into the circuit, our controller will think. This one goes to our blue. check it out now. Look at our evaporator temperature, 55 degrees Celsius. So now our controller thinks the temperature of this evaporator is 55 degrees. So now it'll kick on our compressor. You just heard it click on. Now we can watch. This is the temperature of our evaporator. Look at it going down. The problem with doing this is the compressor now doesn't know when to stop. So this is at risk of freezing over the way we bypassed it. Our value is still going down. We're still showing 55 degrees Celsius. Oh boy, look how cold this thing is. It's starting to ice over. This thing is cold. Still the ice. All right, now we'll turn the machine off because I want to be able to protect the system. All right, it's a couple days later. We've got our new sensor. We pulled out the old one. We've got our airbox taken apart, so we'll swap out our new one with our old one. But first, I want to do a compare test. I'm going to put both of these sensors into a cup of water so that it's going to be reporting the same temperature, and we'll see if the resistance values are different. All right, so I've got a cup of water here that is probably ambient temperature, which is right now maybe between 70 and 80 degrees, and I've got our new sensor hooked up to this meter, and we're reading 30 kiloohms. I've got our old sensor hooked up to this meter, and we're reading 1 kiloohm. So our old sensor is definitely the problem. If both of these sensors were good, we would be reading the same value on both of these. So this is just an extra test, just to kind of clear my mind and verify that I made the right diagnosis. All right, so we're gonna put this one in there, and then we'll go back in with the laptop and we'll look at our temperature value on our evaporator. We've got our new sensor installed. I hooked up my meter so we can look at the actual temperature of the evaporator. Right now we're at 44 degrees. We are seeing 5 degrees Celsius on our evaporator. Look at all that condensation. That is really good. That is a great indication of a well-working AC system. Here, our outlet temp is really nice and cool. This is perfect. So we'll slap our cover back on, put our new cabin air filter, and then we'll measure the temperature coming out from the vent. All right, guys, we're in the cab now. We've got our temperature probe in our vent, and our vent temp is about 46 degrees, and it feels perfect in here. This is a perfect cabin temperature. The operator is going to be really happy. So that's a good diagnosis. That's a good repair. I'm glad that we were able to find that sensor that was measuring our evaporator temperature was all out of whack. Sometimes an input like that can be really hard to find. It's a lot easier to diagnose a problem when you have a bad output. Like a bad output would be, a bad compressor or something like that. But because of that wonky input from that temperature sensor, it was telling our controller in here to do all kinds of stupid things. It was telling our AC module that our evaporator temperature was way too cold. So it was telling our compressor to cycle. But now that we've rectified that, our compressor is able to cycle normally. When that evaporator gets way too cold, it'll cycle off, and it'll keep this temperature at 46 degrees, just like that. So this is a perfect temperature. I'm glad we were able to get this repaired. We're gonna hand this machine back over to the customer, and yep, we're on to the next one.